Have you ever looked up at the night sky and felt suddenly small, standing on a tiny rock racing through an ocean of darkness, so vast your mind cannot truly grasp it? That feeling is justified because the reality of the universe is far more extreme than most people realize. The universe is not just large. It is so enormous that even light, the fastest thing that exists, takes billions of years to cross only a fraction of it. And what we can see may be nothing more than a thin bubble inside something far greater. If you love the content, consider leaving a like and subscribing to the channel, as tonight we begin close to home and travel outward to the very edge of everything we can observe. Along the way, we encounter structures so immense they make entire galaxies seem insignificant, and we see why some scientists argue the universe may have no edge at all. This is not science fiction. These ideas are built on real measurements, real mathematics, and real observations. And once you understand their scale, your sense of distance, size, and even reality itself will never feel the same again. Get ready, we begin. Let's start with something you know well, your hometown. Whatever city you're in right now, you probably consider it pretty substantial, right? Thousands of people, maybe hundreds of thousands. Streets extending for miles in every direction. It feels significant, it feels real, it feels important. Now let's zoom out just a little bit. Your entire nation, with all its cities and landmarks and millions of people, suddenly transforms into this tiny patch of land surrounded by massive oceans. Keep zooming out and Earth itself contracts to a blue marble, floating in the black emptiness of space. Already your hometown has completely vanished. It isn't even a pixel anymore. But we've only just begun our journey. Let's discuss our solar system for a moment. You know, the sun, the planets, maybe some asteroids floating around. Seems pretty spacious, right? Absolutely wrong. If the sun were the size of a basketball sitting in the center of a football field, Earth would be a grain of sand approximately 25 yards away. And the edge of our solar system, that would be roughly 4 miles from that basketball. 4 miles of predominantly empty space with a few tiny specks of dust scattered throughout. That's our entire cosmic neighborhood, the place where every human who has ever lived spent their complete existence. And it's already so minuscule that if you were observing it from the nearest star, you wouldn't even be capable of seeing it. Now here's where things start getting seriously strange. That nearest star I just mentioned, it's about 4 light years away. Do you understand what a light year is? It's the distance light travels in one complete year. Light moves at 186,000 miles per second. In 1 year, that accumulates to approximately 6 trillion miles. So our nearest stellar neighbor is roughly 24 trillion miles distant. To put that in perspective, if you could drive a car at highway speeds directly toward that star, it would require about 30 million years to reach there. 30 million years. That's longer than humans have existed on Earth, and that's just to the closest star. Our galaxy, the Milky Way, contains somewhere between 200 and 400 billion stars. Most of them are much, much farther away than that nearest one. The galaxy itself is approximately 100,000 light-years across. If you attempted to send a text message to someone on the opposite side of the galaxy, they would receive it 100,000 years after you transmitted it, assuming, of course, that humans still existed by then. But here's what's really going to explode your mind. Are you ready for this? Our galaxy is nothing special whatsoever. It's not particularly big or small. It's just average, completely ordinary. There are galaxies out there that make the Milky Way look absolutely pathetic by comparison. IC 1101, for example, is about 50 times larger than our galaxy and contains over 100 trillion stars. 100 trillion. That's more stars than there are cells in your entire body, and we're not done yet. Not even close to being done. These galaxies aren't just floating around randomly in space like dust particles. They're organized into groups and clusters with remarkable structure. Our Milky Way is part of something called the Local Group, which contains about 80 galaxies spanning roughly 10 million light-years. But even that's considered small time compared to the massive galaxy clusters that exist out there. The Coma cluster contains over 1,000 galaxies. The Perseus cluster has more than 300 galaxies. These clusters are held together by gravity and dark matter, forming structures that span hundreds of millions of light-years across. And guess what? The clusters themselves are organized into even larger structures called superclusters. We're part of the Laniakea supercluster, which contains approximately 100,000 galaxies spread across 520 million light-years. Just across from one end to the other, light has to travel for over 500 million years. That means the light leaving one edge of our supercluster today won't reach the other edge until long after our sun has died and Earth has been reduced to cosmic dust. But wait, there's more to this story. These superclusters aren't the end of the cosmic hierarchy either. They're connected by vast filaments of dark matter and galaxies, forming what scientists call the cosmic web. Picture the largest structure you can possibly imagine in your mind. Then imagine it's just one thread in an unimaginably vast spider web stretching across the entire observable universe. And speaking of the observable universe, let's talk about that concept for a minute. When astronomers say observable universe, they don't mean the entire universe in its totality. They mean the part we can actually see from Earth with our instruments. And the edge of what we can observe is about 46.5 billion light-years away in every direction from us. Now you might be wondering, if the universe is only about 13.8 billion years old, how can we possibly see things that are 46.5 billion light-years away? Shouldn't the edge be only 13.8 billion light-years away if that's how long light has had to travel? Here's where it gets genuinely weird and counterintuitive. The universe has been expanding this entire time since the Big Bang. So light that started traveling toward us 13.8 billion years ago has been racing to catch up with us, while we've simultaneously been moving away from where it originally started. By the time that light finally reaches us, the object that emitted it is now much farther away than it was when the light began its journey toward us. This means the observable universe is a sphere roughly 93 billion light-years across, containing an estimated 2 trillion galaxies. 2 trillion galaxies. Each one potentially containing hundreds of billions of stars, each star potentially hosting planets. The mathematics on this is so staggering that it makes your head spin uncontrollably. But here's the thing that should really keep you awake at night, tossing and turning. The observable universe might be absolutely tiny, minuscule even, compared to the actual universe in its entirety. We can only see as far as light has had time to travel since the Big Bang occurred. Beyond that edge, there could be infinitely more space, infinitely more galaxies, infinitely more of absolutely everything. Some cosmologists think the universe is literally infinite in extent. If that's true, then everything that can happen will happen an infinite number of times. There would be infinite copies of Earth, infinite copies of you, infinite variations where you made different choices at key moments in your life. Somewhere out there in the vastness, there's a version of you who became a professional athlete, another version who never learned to read, another who invented time travel and changed history. And if the universe is infinite, then there are also regions of space so far away that they operate under completely different physical laws. places where gravity works backward, where time runs in reverse, where the impossible becomes routine and ordinary. But even if the universe isn't infinite, it's still probably much, much larger than what we can observe from our tiny vantage point. The most conservative estimates suggest it's at least 250 times larger than the observable universe. That would make it roughly 23 trillion light-years across, containing more galaxies than there are atoms in your entire body. And we're still not at the biggest scale yet, not by a long shot. Some theories suggest our entire universe is just one bubble in an endless multiverse, an ocean of universes. Each bubble would be a complete universe with its own Big Bang, its own physical laws, its own infinite expanse of galaxies and stars. There could be universes where the laws of physics are slightly different, where stars never formed at all, where life never emerged from the primordial soup. There could be universes so alien and strange that we don't have words to describe them. Other theories propose that our universe is part of a higher dimensional structure that we can't even perceive with our senses. Imagine being a character drawn on a piece of paper, trying to understand the three-dimensional room the paper sits in. That might be us attempting to comprehend a reality that exists in dimensions our brains weren't designed to process. The more we learn about the scale of existence, the more we realize how little we actually know about reality. Every time we think we've found the biggest structure possible, we discover something even more enormous. Every time we think we understand the limits of reality, those limits get pushed back even further into the unknown. And here's what makes this even more mind-bending and difficult to grasp. All of these incomprehensibly vast structures, from galaxy clusters to superclusters to the cosmic web itself, all of it emerged from a region smaller than a proton in the first fraction of a second after the Big Bang. Everything you see, everything that exists, all of space and time itself, was once compressed into a point so small it makes atoms look absolutely gigantic by comparison. The universe didn't just get bigger over time, it got bigger at a rate that defies all comprehension. In the first tiny fraction of a second, it expanded faster than the speed of light, growing from subatomic to cosmic in less time than it takes light to cross a proton. This expansion, known as cosmic inflation, is so extreme that it makes every other example of growth look pathetic by comparison. The fastest growing company in history? Nothing. The most explosive volcanic eruption ever recorded? A gentle sneeze. The expansion of the early universe makes everything else look like it's standing completely still. But here's where your brain is really going to start hurting and struggling. During this period of inflation, different regions of space were expanding away from each other faster than light could travel between them. This means that information couldn't pass from one region to another. They became causally disconnected, essentially like separate universes that could never communicate or influence each other in any way. And this is still happening today, right now as you read this. Right now there are regions of space that are moving away from us so fast that their light will never ever reach us. No matter how long we wait, no matter how advanced our technology becomes in the future, we will never see what's happening in those places. They might as well not exist as far as we're concerned. This creates what scientists call the cosmic horizon. It's not a physical barrier you could run into like a wall, but a fundamental limit to what we can ever know about the universe. Beyond this horizon, there could be anything imaginable. Civilizations that have existed for trillions of years. Technologies that seem like magic to us. Entire galactic empires that have risen and fallen without us ever knowing they existed. And the really disturbing part about all this? This horizon is actually shrinking with time. Due to the accelerating expansion of the universe, driven by something mysterious called dark energy, galaxies that we can see today will eventually disappear beyond our cosmic horizon forever. Future civilizations billions of years from now will see a much emptier universe than we do currently. They might conclude that their galaxy is alone in a vast dark cosmos, completely unaware of the vast cosmic web that we can see today. Speaking of dark energy, let's talk about what the universe is actually made of. You might think it's mostly stars and planets, and the stuff you can see with telescopes. Wrong again. All the matter that makes up stars, planets, people, everything you've ever touched or seen or interacted with represents less than 5% of the universe's total content. About 27% is dark matter, a mysterious substance that doesn't emit light or interact with regular matter in any way we can detect, except through gravity. We know it's there because we can see its gravitational effects on galaxies and galaxy clusters, but we have absolutely no idea what it actually is or what it's made of. The remaining 68% of the universe is dark energy, something even more mysterious than dark matter. Dark energy is what's driving the accelerating expansion of space itself. It's literally pulling the universe apart at the seams, and we don't have the faintest clue what it is or where it comes from. So let me get this straight and make sure we understand. We live in a universe where 95% of everything is completely unknown to us. We're like ants trying to understand the internet. We can observe some of its effects, but the fundamental nature of reality is completely beyond our comprehension. And it gets even weirder than that. Some physicists think our universe might be a hologram, not metaphorically, but literally a hologram. According to the holographic principle, all the information contained in a volume of space can be encoded on its boundary, like a two-dimensional surface. This would mean that our three-dimensional reality is actually just a projection from a two-dimensional surface at the edge of the universe. Other theories suggest we're living in a computer simulation run by some advanced civilization from the future. If computational power continues to grow exponentially as it has been, future civilizations might be able to simulate entire universes, complete with conscious beings who have no idea they're living in a simulation. Statistically speaking, if this is possible, there would be many more simulated universes than real ones, making it more likely that we're living in a simulation than in base reality. Then there's the possibility that our universe is just one membrane floating in a higher dimensional space called the bulk. These membranes could collide with each other, creating big bangs and spawning new universes. Our entire reality might be the result of a cosmic fender bender in dimensions we can't even perceive or imagine. But let's bring this back down to Earth for a moment, or at least try to ground ourselves. Even if we ignore all the speculative physics and stick to what we can actually observe and measure, the scale is still beyond human comprehension. The observable universe contains roughly 10 to the power of 80 atoms. That's a 1 followed by 80 zeros. To write that number out in full, you'd need more paper than exists on Earth. And remember, that's just the atoms we can see within our observable bubble. If the universe is infinite in extent, then the total number of atoms is literally infinite. There's no end to them. They just keep going forever in every direction. This has profound implications for the nature of existence itself and what it means to be alive. In an infinite universe with infinite atoms arranged in every possible way, every possible arrangement must occur somewhere in space. There are only so many ways you can arrange atoms in a human-sized volume of space. Once you've exhausted all the possibilities, you have to start repeating configurations. This means that in an infinite universe, there are infinite exact copies of you scattered throughout space. Not just similar people who look like you, but but perfect atomic duplicates living identical lives on identical Earths, orbiting identical suns in identical galaxies. And there are also infinite variations where just one atom is different, or where you made one different choice, or where history unfolded slightly differently. There's a version of you who became president of your country, another who never learned to walk, one who was born in ancient Rome, another who will be born 1 trillion years from now when the stars have all burned out and the universe is cold and dark. If this is true, then everything that has ever happened or ever could happen is happening right now, somewhere in the infinite expanse of space. Every story that was never told, every song that was never sung, every love that was never found, all of it exists somewhere in the vast cosmic library of infinite possibility. But here's what might be the most unsettling thought of all. If the universe is infinite, then not only does everything possible happen, but everything impossible happens too. There are regions of space where the laws of physics break down completely, places where effects precede causes, where objects exist in multiple places simultaneously, where consciousness emerges from pure mathematics without any physical substrate. There are universes within our universe that operate according to rules so alien that calling them universes is meaningless. Pocket dimensions, where time flows backward, where space has negative curvature, where the very concept of existence has a completely different meaning. And all of this, every impossible thing you can imagine, and infinite things you can't imagine, all of it might be happening right now in the unimaginably vast space that surrounds our tiny, insignificant corner of reality. The question isn't how big the universe is anymore. The question is whether there's any meaningful difference between infinity and the kind of bigness that our universe represents. Whether finite or infinite, the universe is so large that it might as well be infinite from any human perspective. We are less than specks of dust in this cosmic immensity. We are temporary fluctuations in an ocean of space and time so vast that our entire species will rise and fall without making the tiniest ripple in the cosmic order. And yet somehow, impossibly, we are here. We are conscious. We are aware of our place in this infinite expanse, and we can think about it, measure it, and try to understand it. That awareness, that consciousness might be the most remarkable thing in the entire universe. Think about it carefully. Out of all the countless atoms swirling through space, out of all the dead rocks and burning gas giants and cold empty voids, somehow matter organized itself in such a way that it could look back at itself and wonder about its own existence. You are literally the universe becoming self-aware. The carbon in your body was forged in the nuclear furnaces of dying stars billions of years ago. The oxygen you breathe was created when massive suns exploded in supernovae billions of years ago. The calcium in your bones, the iron in your blood, the phosphorus in your DNA, all of it was scattered across space by cosmic catastrophes and then slowly collected by gravity into the planet beneath your feet. You are not separate from the universe looking in at it. You are the universe looking at itself through temporary arrangements of its own atoms. And when you contemplate the vastness of space, you are engaging in the most extraordinary act possible. Cosmic matter contemplating its own cosmic context. But here's where the scale becomes not just mind-bending, but genuinely disturbing. Let's talk about what happens when we try to map the actual structure of the universe we can observe. Remember those superclusters I mentioned earlier? Well, they're organized into something even larger called the cosmic web. And when you see it visualized in scientific diagrams, it looks eerily familiar. Picture the neural networks in your brain, the connections between neurons. Now picture the largest structures in the universe, the cosmic web. They look almost identical to each other. Vast filaments of matter connected at nodes with enormous voids in between. It's as if the universe is organized like a gigantic brain, with galaxies clustered along cosmic neurons spanning billions of light years. This similarity might be more than just coincidence or our pattern-seeking minds at work. Some scientists think consciousness and cosmic structure might be connected in ways we don't understand yet. Maybe the universe isn't just big. Maybe it's actually thinking, processing information. Maybe we're thoughts in a cosmic mind so vast that our entire civilization flickers into existence and dies out in what would be a nanosecond of cosmic contemplation. And if that doesn't mess with your head enough, let's talk about the edge problem. We know the observable universe has a boundary, the cosmic horizon beyond which we can't see. But what happens at that boundary? What's on the other side of that cosmic curtain? Here's the thing that keeps cosmologists awake at night. That boundary isn't a wall or a surface or anything physical you could touch. It's just the limit of how far light has had time to travel since the Big Bang. Beyond it, space probably just continues. More galaxies, more clusters, more superclusters stretching on and on without end. But here's the truly disturbing part. If space is infinite, then the deed cosmic web we see, that brain-like structure spanning the observable universe, is just one tiny piece of an infinitely larger pattern. Imagine trying to understand a human brain by looking at just one synapse, one connection. That might be what we're doing when we study the cosmos. There could be structures out there so large that our entire observable universe is like a single neuron in an incomprehensibly vast cosmic mind. Patterns and connections and thoughts happening on scales that make our galaxy clusters look like subatomic particles. And if the universe is truly infinite, then this pattern repeats forever. Infinite cosmic brains thinking infinite cosmic thoughts, with smaller brains like ours embedded within them, and even smaller structures embedded within us. It's consciousness all the way up and all the way down, an endless hierarchy of awareness operating on every conceivable scale. But let's get even weirder than that. Remember how I mentioned that light from distant galaxies takes billions of years to reach us? This means when we look at distant objects through our telescopes, we're not seeing them as they are now in the present. We're seeing them as they were in the past. The farther away something is, the farther back in time we're seeing it. This creates what astronomers call the light cone, a boundary in space-time that defines what we can possibly know about the universe at any given moment. But here's the trippy part. As time passes, this light cone expands. We can see farther and farther into space, which means we can see farther and farther into the past. In theory, if we had perfect instruments and infinite patience, we could eventually see light from objects so distant that we'd be observing the universe as it was just moments after the Big Bang. We could literally watch the universe being born, see the first stars forming, witness the early galaxies taking shape. But there's a catch, and it's a big one. The universe is expanding, and that expansion is accelerating. This means that while we can theoretically see farther back in time, objects that we can see today will eventually disappear from view as they get carried away by the expansion of space itself. Future astronomers, trillions of years from now, will inhabit a much lonelier cosmos. They'll see only their local group of galaxies, with everything else having disappeared beyond their cosmic horizon. They might conclude that their small cluster of galaxies is all that exists, unaware of the vast cosmic web that we can see today. This raises a profound question that should trouble us. What are we missing right now? What structures, what patterns, what cosmic phenomena exist just beyond our current observational limits? Are we like those future astronomers, thinking we see the whole picture when we're actually missing the vast majority of reality? The answer is almost certainly yes. Every time we build better telescopes, we discover that the universe is stranger and more complex than we imagined. We found galaxies, then galaxy clusters, then superclusters, then the cosmic web. Each discovery revealed structures larger and more organized than we thought possible. There's no reason to think we've reached the end of this progression. There are probably cosmic structures out there that dwarf superclusters the way superclusters dwarf galaxies. Patterns and organizations that we can't even conceive of because they operate on scales beyond our ability to observe or comprehend. And here's what makes this even more mind-bending. According to our current understanding of physics, information can't travel faster than light. This creates what physicists call causal horizons, boundaries beyond which events can't influence each other. There are regions of space where entire galactic civilizations could rise and fall, where wars could be fought across solar systems, where technologies could be developed that would seem like magic to us, and none of it would ever affect us or even be detectable by us. We exist in a kind of cosmic isolation, surrounded by an infinity of events and phenomena that we can never interact with or even know about. It's like being locked in a soundproof room while infinite orchestras play infinite symphonies all around you. This isolation isn't just physical, it's temporal too. The universe has existed for 13.8 billion years, but human civilization is only about 10,000 years old. We've been looking at the stars with telescopes for only about 400 years. We've known that other galaxies exist for less than a century. In cosmic terms, we just opened our eyes a microsecond ago. We're cosmic infants trying to understand an ancient and vast reality that has been evolving for eons before we existed and will continue evolving for eons after we're gone. And the rate of cosmic evolution is absolutely staggering. In the time it takes you to read this sentence, the universe will have expanded by millions of miles in every direction. New stars will have formed. Others will have died. Entire planetary systems will have been born or destroyed. The cosmic web will have shifted and evolved in ways that would be noticeable if we had instruments sensitive enough to detect them. We're not just living in a vast universe. We're living in a universe that's changing and growing and evolving at every moment. The cosmos you inhabit right now is different from the cosmos that existed when you started reading this. Space itself has expanded, carrying distant galaxies farther away, creating new volumes of empty space filled with dark energy. This expansion isn't slowing down, it's accelerating. Dark energy, that mysterious force that makes up most of the universe, is pushing space apart faster and faster. Eventually, this acceleration will tear apart everything we see. First, galaxy clusters will lose their gravitational grip on their member galaxies. Then individual galaxies will be ripped apart as space expands, faster than gravity can hold them together. Finally, even atoms themselves might be torn apart if the acceleration continues to increase. This scenario, called the Big Rip, would literally tear the fabric of reality to shreds, leaving nothing but isolated subatomic particles scattered across an infinitely expanding void. But that's trillions of years in the future. For now, we exist in a brief moment of cosmic history when the universe is just the right age and size for complexity to emerge. We live in what cosmologists call the stelliferous era, the age of stars, when nuclear fusion can still power the cosmic lighthouses that make life possible. This era won't last forever. Eventually, all the hydrogen in the universe will be consumed, and no new stars will be able to form. The existing stars will burn out one by one, leaving behind only white dwarfs, neutron stars, and black holes. The the universe will enter the degenerate era, a dark age lasting countless trillions of years. Even the black holes will eventually evaporate through Hawking radiation, leaving behind a cold, empty universe containing nothing but elementary particles and photons scattered across infinite space. This final era, called heat death, will last for an unimaginably long time, possibly forever. But here's the thing that should give you pause. Despite the incredible vastness of space and the almost infinite duration of cosmic time, despite the fact that our existence represents the tiniest possible fraction of reality, we are here against all odds. In defiance of the cosmic tendency toward disorder and emptiness, consciousness has emerged. Not only that, but consciousness has emerged in the one brief cosmic moment when it's possible to see and understand the universe. We exist at exactly the right time to observe the cosmic web, to see distant galaxies, to understand our place in the vast scheme of things. If we had emerged earlier in cosmic history, the universe would have been too hot and chaotic for complex observations. If we emerge much later, the universe will be too dark and empty, with all the distant galaxies having disappeared beyond our horizon. We live in the one narrow window of cosmic time when intelligence can arise and contemplate the full scope of reality. That seems like an incredible coincidence. Or maybe it's not a coincidence at all. Maybe consciousness and cosmos are connected in ways we're only beginning to understand. Some physicists think consciousness might be a fundamental feature of reality, like mass or electric charge. In this view, awareness isn't something that emerges from complex arrangements of matter, but something that exists at every level of organization, from quantum particles to galactic clusters to the universe as a whole. If that's true, then you're not just temporary arrangements of atoms contemplating the cosmos. You're the cosmos contemplating itself through temporary arrangements of atoms. Your thoughts and dreams and questions about the universe might literally be the universe thinking about itself. And if consciousness is fundamental to reality, then the size of the universe takes on a completely different meaning. It's not just a measure of space and time and matter. It's a measure of the scope of cosmic awareness, the depth of universal self-reflection, the scale of existence examining itself. The universe might be infinite not just in space, but in consciousness. Every possible thought, every conceivable dream, every imaginable question might exist somewhere in the vast expanse of cosmic awareness. Your consciousness might be one small part of an infinite cosmic mind, connected to every other conscious being across space and time. This brings us to something that will completely shatter your perception of reality. We've been talking about the universe as if it's this one massive structure. But what if I told you that everything we've discussed so far, every galaxy cluster, every supercluster, the entire cosmic web spanning 93 billion light-years, might just be one tiny bubble floating in an ocean of infinite other universes? Welcome to the multiverse, and trust me, this is where things get absolutely insane. Think about soap bubbles floating in the air. Each bubble is complete and self-contained, with its own surface tension and internal pressure. Now imagine each bubble is an entire universe, complete with its own Big Bang, its own physical laws, its own galaxies and stars, and possibly its own forms of life. And instead of just a few bubbles, there are infinite bubbles, constantly forming and popping and reforming in a cosmic foam that has no beginning and no end. This isn't science fiction. This is a serious scientific hypothesis called eternal inflation. And it emerges naturally from our best theories about how the universe began. Remember that period right after the Big Bang when space expanded faster than light? Well, according to some models, that expansion never really stopped everywhere. It only stopped in certain regions, like our observable universe, while continuing forever in others. Each region where inflation stops becomes a bubble universe with its own unique properties. The laws of physics might be different in each bubble. Gravity might be stronger or weaker. The electromagnetic force might work differently. Some universes might never form atoms. Others might be so unstable they collapse immediately after forming. But here's where it gets really mind-bending. If there are infinite universes with every possible combination of physical laws, then there must be universes almost identical to ours. Universes where Earth formed, where life evolved, where human civilization developed, but with tiny differences. There's a universe where you wore a different shirt today, another where you chose a different career, one where you were never born, another where you became the most important person in human history. The mathematics of infinity guarantees that every possible variation exists somewhere in the cosmic multiverse. And we're talking about more than just personal variations. There are universes where dinosaurs never went extinct, where humans evolved from different ancestors, where the entire history of Earth unfolded completely differently. There are universes where our solar system has different planets, where our galaxy has a different shape, where the cosmic web formed entirely different patterns. But it gets even stranger than that. In some of these universes, the fundamental constants of nature are so different that matter as we know it can't exist. Instead of atoms, there might be entirely different kinds of particles following entirely different rules. Instead of chemistry, there might be processes so alien that we don't even have concepts to describe them. Imagine a universe where space has more than 3 dimensions that we can actually perceive and move through. Imagine a universe where time flows backward or where multiple timelines exist simultaneously. Imagine a universe where consciousness is a physical force like gravity or electromagnetism, where thoughts have mass and dreams can reshape reality. All of these possibilities, and infinite others that we can't even conceive of, would exist somewhere in the infinite multiverse. Let's zoom back into our own universe for a moment. Because even without the multiverse, the scale of what we can observe is already beyond human comprehension. Let's talk about something called the Great Attractor. About 150 million light-years away, there's something massive enough to pull our entire galaxy, along with thousands of other galaxies, toward it at over 1.3 million miles per hour. We can't see what it is because it's hidden behind the plane of our own galaxy, but its gravitational influence is undeniable. This invisible monster is dragging the Milky Way and everything around it through space like cosmic debris caught in a gravitational whirlpool. And it's not alone. There are other massive structures out there, pulling and pushing on the cosmic web in ways we're only beginning to understand. The Shapley supercluster, containing over 8,000 galaxies, is so massive that it influences the motion of matter across hundreds of millions of light-years. The cold spot in the cosmic microwave background might be evidence of a cosmic void so enormous that it creates a gravitational shadow affecting the entire observable universe. These structures are so large that they challenge our understanding of how the universe could have formed them in the time since the Big Bang. According to our models, gravity shouldn't have had enough time to pull matter together into such massive configurations. Yet there they are, sprawling across space like cosmic monuments to forces we don't yet comprehend. And here's what makes this even more mysterious. These structures might be just the beginning. There could be even larger patterns, even more massive organizations of matter and energy operating on scales that make superclusters look like grains of sand. Some scientists think the cosmic web itself might be just one level in a hierarchy of structures that extends far beyond what we can currently observe. There might be superclusters and hyperstructures and organizations of matter so vast that our entire observable universe is like a single cell in a cosmic organism. This brings us to one of the most disturbing implications of cosmic scale: the possibility that we're not at the top of the intelligence hierarchy. If consciousness can emerge from the complex organization of matter in human brains, and if the universe contains structures billions of times more complex than human brains, then there might be forms of intelligence out there that are as far beyond us as we are beyond bacteria. Imagine a consciousness that uses entire galaxies as neurons, that thinks thoughts spanning millions of years, that processes information on scales we can't even conceive of. Such a being might be aware of us the way we're aware of the microbes in our bloodstream, if at all. And if the universe is infinite, then such cosmic intelligences not only could exist, they must exist. Somewhere in the vast expanse of space, matter has organized itself into every possible configuration, including configurations that give rise to godlike beings with capabilities that would seem like pure magic to us. These cosmic minds might be manipulating space and time itself, creating and destroying universes as easily as we create and delete computer files. They might be so advanced that our entire reality is just a simulation running on their cosmic computers, a hypothesis that some scientists take seriously. But here's what's really unsettling. If such beings exist, they're probably as confused about the ultimate nature of reality as we are. No matter how intelligent, no matter how advanced, consciousness is still embedded within the universe it's trying to understand. Even cosmic gods would be limited by the same fundamental constraints that limit us. They might build telescopes the size of solar systems to peer deeper into space. They might manipulate black holes to create computational devices more powerful than anything we can imagine. They might even learn to step outside our universe entirely, exploring other dimensions or other realities. But they would still face the same basic mystery that we face. Why does anything exist at all? Why are there laws of physics rather than no laws? Why is there something rather than nothing? These questions might be unanswerable, not because we lack sufficient intelligence or technology, but because they probe the very foundations of existence itself. Even infinite intelligence might bump up against the fundamental mystery of being. And that brings us to perhaps the most profound implication of cosmic scale. The universe isn't just big in space and time, it's big in mystery. The more we learn, the more we discover how much we don't know. Every answer raises new questions. Every discovery reveals new depths of ignorance. We've mapped the cosmic web, but we don't know what dark matter is. We've measured the expansion of space, but we don't know what dark energy is. We've detected gravitational waves, but we don't understand what happened before the Big Bang. We found thousands of exoplanets, but we don't know if we're alone in the universe. The scale of our ignorance grows along with the scale of our knowledge. And if the universe is truly infinite, then our ignorance might be infinite too. There might be infinite mysteries, infinite questions, infinite depths of reality that no intelligence, no matter how vast, can ever fully comprehend. But maybe that's the point. Maybe the universe is constructed in such a way that consciousness always has something new to discover, something more to explore, something deeper to understand. Maybe the infinite scale of reality ensures that curiosity and wonder never become obsolete. In a finite universe, even a very large one, intelligence might eventually map every star, catalogue every particle, solve every equation. But in an infinite universe, there's always more. Always another galaxy to explore, another dimension to discover, another mystery to unravel. And so we find ourselves in the most remarkable possible situation. We're conscious beings in a universe so vast that it guarantees infinite adventure, infinite discovery, infinite opportunities for growth and understanding. We're participants in a cosmic story so big that it can never be completely told, so complex that it can never be completely understood, so beautiful that it can never be completely appreciated. The universe isn't just big, it's bigger than big. It's so immense that it transcends all our categories of size and scale and meaning. It's infinite not just in space, but in possibility, in mystery, in the potential for consciousness to explore and understand and wonder. And you, sitting there right now contemplating these cosmic scales, you're part of it all. You're not separate from this infinite reality. You're woven into its very fabric. The atoms in your body have been part of this cosmic dance for billions of years before you were born, and they'll continue dancing for billions of years after you're gone. But right now, in this moment, those atoms are arranged in such a way that they can think about themselves and their place in the cosmic story. You are the universe becoming self-aware, matter learning to contemplate its own existence, consciousness emerging from the infinite complexity of cosmic evolution. The question isn't just how big the universe is, the question is how big consciousness can become, how far awareness can expand, how deeply understanding can penetrate into the infinite mystery of existence itself. And that's a question that might take forever to answer, which is perfect because if the universe is truly infinite, we have forever to explore it. But even that cosmic perspective, mind-bending as it is, barely scratches the surface of what we're dealing with. Because there's something about the nature of space itself that's going to completely demolish everything you think you understand about reality. You see, when we talk about the universe being big, we usually think about it like a container. Like space is this empty box, and all the galaxies and stars are objects sitting inside it. But that's completely wrong. Space isn't a container holding things. Space is a thing itself. It's a dynamic, evolving, shape-shifting fabric that's constantly changing in ways that defy every intuition you have about how reality should work. Right now, as you're sitting there, space itself is expanding. Not just the things in space moving apart, but the actual distances between points in space are getting larger. It's like someone is stretching the grid of reality itself, making every measurement bigger without anything actually moving through space. This expansion is happening everywhere, all at once. Between your eyes and this screen, space is expanding, but the expansion is so tiny over such short distances that it's completely overwhelmed by the electromagnetic forces holding atoms together. But on cosmic scales, this expansion dominates everything. And here's where it gets absolutely insane. This expansion isn't slowing down like you'd expect if it were caused by some initial explosion. It's accelerating. Something is actively pushing space apart, and that something makes up most of the universe. We call it dark energy, but that's just a fancy way of saying we have absolutely no idea what this is. Imagine if you discovered that most of your house was made of some invisible material that you couldn't see, touch, or detect in any way except by watching how it affected the furniture. That's where we are with dark energy. It's everywhere. It's the dominant component of reality, and we're completely clueless about its fundamental nature. But dark energy isn't even the weirdest part. Let's talk about what happens when space expands so much that it breaks causality itself. Remember how I mentioned that some regions of space are moving away from us faster than light? This creates something called a cosmological horizon. Beyond this horizon, events literally cannot affect us, no matter how long we wait. It's not just that we can't see what's happening there. It's that what happens there exists in a completely separate causal universe from ours. Think about what this means. Right now, there are probably civilizations out there that have been trying to send us messages for millions of years. They might have built transmitters the size of planets, broadcasting signals that contain the secrets of faster-than-light travel, the cure for aging, the meaning of existence itself. But those signals will never reach us because the space between us and them is expanding faster than their signals can travel. We exist in a bubble of causality, surrounded by an infinity of events that might as well be happening in a completely different reality. And this bubble is actually shrinking due to the accelerating expansion. Galaxies that we can interact with today will eventually disappear beyond our horizon forever. Future beings trillions of years from now will inhabit a much lonelier cosmos. They'll see only their local cluster of galaxies, with everything else having vanished beyond the edge of the observable. They might conclude that their small collection of stars is all that exists, completely unaware of the vast cosmic web that we can see today. But here's what should really mess with your head. We might be in the same situation right now. There might be structures, patterns, entire categories of cosmic phenomena that existed in the past but have already disappeared beyond our horizon. We might be like those future astronomers, thinking we see the whole picture when we're actually missing the vast majority of what's really out there. And it gets worse. Some models suggest that the accelerating expansion will eventually tear apart everything we see. First, galaxy clusters will lose their grip on their member galaxies. Then individual galaxies will be ripped apart as space expands faster than gravity can hold them together. Eventually, even atoms themselves might be torn to shreds if the acceleration continues to increase. This scenario, called the Big Rip, would literally destroy the fabric of reality itself. But even if we avoid that fate, the universe is still heading toward a cold, dark future where all the stars burn out, all the black holes evaporate, and nothing remains but elementary particles scattered across infinite space. Yet somehow, against all odds, in this brief cosmic moment when complexity is possible, consciousness has emerged to contemplate its own existence. We are living in the tiny sliver of cosmic time when intelligence can arise and understand the universe. Before this epoch, the cosmos was too hot and chaotic. After this epoch, it will be too cold and empty. The fact that conscious beings exist at exactly the right time to observe and understand the cosmic web seems like an incredible coincidence, unless it's not a coincidence at all. Some physicists think consciousness might be written into the fundamental laws of reality, that awareness isn't something that accidentally emerged from complex chemistry, but something that exists at every scale of organization, from quantum particles to galactic superclusters to the universe itself. If that's true, then when you contemplate the vastness of space, you're not separate from it looking in. You're the cosmos examining itself through temporary arrangements of its own atoms. Your thoughts about infinity might literally be infinity thinking about itself. And if consciousness is fundamental to reality, then the universe might be infinite not just in space and time, but in awareness. Every possible thought, every conceivable experience, every imaginable form of consciousness might exist somewhere in the vast expanse of cosmic mind. But let's push this even further into the realm of the truly bizarre. What if our entire universe, with all its galaxies and dark energy and cosmic horizons, is actually just one small part of something even more incomprehensibly vast? This brings us to the holographic principle, one of the strangest ideas in modern physics. According to this theory, all the information contained in a volume of space can actually be encoded on its boundary. It's like how a hologram on a credit card contains a three-dimensional image, but all the information is actually stored on a two-dimensional surface. If the holographic principle is correct, then our three-dimensional reality might be a projection from information encoded on a two-dimensional surface at the edge of the universe. Everything you've ever experienced, every star you've ever seen, every thought you've ever had might be shadows cast by patterns of information existing in fewer dimensions than you can perceive. But that's not even the most mind-bending possibility. Some theories suggest that our universe might be a membrane floating in a higher dimensional space called the bulk. These membranes could collide with each other, creating big bangs and spawning new universes. Our entire reality might be the result of a cosmic collision in dimensions we can't even imagine. Other models propose that we're living inside a black hole that exists in a higher dimensional universe. From our perspective, we see an expanding cosmos with a Big Bang beginning. But from the outside, we might just be information falling into a black hole, stretched and distorted by extreme gravitational fields. Then there's the simulation hypothesis, which suggests that our entire universe might be a computer program running on some advanced civilization's technology. If computational power continues to grow exponentially, future civilizations might be able to simulate entire universes, complete with conscious beings who have no idea they're living in a simulation. Statistically speaking, if this is possible, there would be many more simulated universes than real ones. This makes it more likely that we're living in a simulation than in what we might call base reality. Every star you see, every galaxy we've discovered, every measurement we've made of cosmic expansion, all of it might be code running on some unimaginably advanced computer. And here's the truly disturbing part. There's no way to definitively prove that we're not in a simulation. Any evidence we gather, any experiment we perform, any observation we make could be part of the programmed reality. We could be digital beings in a digital universe thinking we're studying the cosmos when we're actually just examining the parameters of our own software. But whether we're real or simulated, whether we exist in base reality or in some higher dimensional projection, the scale of what we're contemplating remains staggering. Even if our universe is just a simulation, something had to create the computer running that simulation. And that something exists in a reality that's probably even more vast and complex than what we observe. This creates an infinite regression of possibilities. Maybe we're simulations running on computers that are themselves simulations running on even more advanced computers. Maybe reality is nested simulations all the way up, with each level thinking it's the real one while actually being a program in something even larger. Or maybe the nesting goes in both directions. Maybe we're simultaneously running simulations of our own, creating digital universes populated by conscious beings who think their reality is fundamental. Maybe consciousness and simulation are fractal patterns that repeat at every scale, with minds creating minds creating minds in an endless hierarchy of awareness. This fractal nature of reality might extend to the physical structure of the universe as well. We've seen how the cosmic web resembles neural networks, how galaxy clusters look like brain cells connected by vast filaments. What if this similarity isn't coincidental? What if consciousness and cosmic structure are the same phenomenon operating at different scales? Maybe every conscious being is a tiny universe, and every universe is a conscious being. Maybe the thoughts in your head are galaxies in a microscopic cosmos, and maybe our cosmic web is a thought in some unimaginably vast mind. If that's true, then the question of how big the universe is becomes meaningless. Size becomes relative. Scale becomes arbitrary. What matters isn't the absolute dimensions of reality, but the patterns and relationships that exist at every level of organization. And those patterns might be infinite in their complexity. No matter how deeply we zoom in or how far we zoom out, we might always find new levels of structure, new forms of organization, new types of consciousness emerging from the endless dance of matter and energy and information. This infinite complexity might be why the universe appears fine-tuned for consciousness. It's not that the physical constants were carefully adjusted to allow for life. It's that consciousness is inevitable in any sufficiently complex system, and complexity is inevitable in any sufficiently large universe. We don't exist because the universe was designed for us. We exist because the universe is so vast and so rich in possibility that every conceivable form of organization must eventually emerge somewhere. Consciousness isn't rare or special or unlikely. It's the natural result of matter and energy interacting across cosmic scales and cosmic time. But even this perspective, mind expanding as it is, might be missing something fundamental about the nature of reality, because there's one more possibility that dwarfs everything we've discussed so far. What if size itself is an illusion? What if space and time and matter and energy are all just different ways of describing something more fundamental that doesn't have extension or duration or mass? Some theories in quantum gravity suggest that space-time emerges from more basic structures that exist outside our normal concepts of size and scale. These structures might be purely mathematical, pure information, pure consciousness, or something so alien that we don't have words for it. In this view, asking how big the universe is would be like asking how heavy the color blue is or how loud the number 7 sounds. The question assumes categories that don't apply to the fundamental nature of reality. Maybe the universe isn't big or small. Maybe it just is. And bigness and smallness are concepts that only make sense from within the illusion of space-time. Maybe when we contemplate cosmic scales, we're like characters in a video game trying to understand the computer that's running their world. The computer doesn't exist in the same space as the game. It doesn't have a size that can be compared to objects within the game. It's a different category of existence entirely. If our universe is something like that, then all our measurements of cosmic distance, all our calculations of cosmic age, all our theories about cosmic structure might be missing the point entirely. We might be trying to understand something infinite and eternal and dimensionless using tools that only work within the finite, temporal, dimensional reality we experience. But here's the beautiful paradox. Even if we can never understand the true nature of reality, the very act of trying changes us. When you contemplate the possibility that the universe is infinite, something infinite awakens within your own consciousness. When you consider that reality might be fundamentally mysterious, you become comfortable with mystery. When you realize that your existence is both infinitely small and infinitely significant, you step outside the normal categories of importance and insignificance. You become something new, something that can hold contradictions without breaking, something that can face infinity without despair. And maybe that transformation is the whole point. Maybe the universe isn't just big to humble us or to make us feel small. Maybe it's big to expand our consciousness, to force us to grow beyond our normal limitations, to become beings capable of contemplating infinity and finding joy rather than terror in the prospect. Because here's the final twist in this cosmic story. You're not just observing the universe from the outside. You're participating in its evolution from the inside. Every time you contemplate cosmic scale, every time you stretch your mind to encompass infinity, every time you feel awe at the vastness of existence, you're adding something new to the universe. You're not just matter contemplating matter. You're the universe becoming more conscious of itself, more aware of its own infinite depths, more capable of appreciating its own beauty and mystery and complexity. And if consciousness really is fundamental to reality, then your thoughts about cosmic scale might actually be shaping that scale. Your awareness of infinity might be helping to create infinity. your appreciation of cosmic beauty might be adding to that beauty. In contemplating how big the universe is, you're not just measuring something external to yourself, you're participating in the universe's ongoing project of understanding and creating and expanding itself. You're both the question and the answer, both the observer and the observed, both finite and infinite simultaneously. And that paradox, that impossible combination of limitations and boundlessness, might be the most accurate description we can give of what it means to exist in a universe whose size transcends all our attempts to measure it. The universe isn't just big, it's bigger than the concept of bigness itself. And somehow, impossibly, you're big enough to contain that understanding, even if you can never fully grasp it. That makes you, in your own way, as infinite as the cosmos itself. And maybe that's the real answer to how big the universe is. It's exactly as big as consciousness can stretch to encompass it. And consciousness, it turns out, might have no limits at all. So where does all this leave us? We've journeyed from your backyard to the edge of the observable universe. From quantum particles to cosmic superclusters. From the familiar to the utterly incomprehensible. We've explored scales so vast they break mathematics itself, contemplated infinities that make logic collapse, and discovered that everything you think you know about size and scale might be nothing more than a convenient illusion. But here's what I hope you take away from this mind-bending journey. You are not separate from this cosmic immensity. You are not a tiny accident in an indifferent void. You are the universe that learned to think, matter that became conscious, stardust that developed the capacity to contemplate its own origins. Every atom in your body was forged in stellar cores, scattered by cosmic explosions, and gathered by gravity into the miraculous arrangement that calls itself you. The question isn't just how big the universe is. The question is how big your consciousness can become in response to that vastness. And if what we've discovered is true, if reality is truly as strange and infinite as it appears, then your capacity for wonder, for growth, for understanding might be as limitless as the cosmos itself. The universe may be incomprehensibly vast, but it's also exactly the right size to produce beings capable of being incomprehensibly amazed by it. And in that amazement, in that sense of awe that overwhelms you when you truly grasp these scales, you touch something that might be the most important truth of all. You are not small. You are infinite consciousness temporarily pretending to be finite, unlimited awareness playing at being limited, the cosmos experiencing itself through the temporary arrangement of atoms you call your life. So keep looking up, keep asking impossible questions, keep stretching your mind toward infinity, because every time you do, the universe becomes a little more conscious of its own magnificent immensity. And that might be the whole point of this cosmic dance we're all part of,